Bismillah ar-Rahman ar-Rahim. Alhamdulillah, wassalatu wassalamu ala Rasulillah. Yes, I will continue the discussion about Hess law, which we started last time, and then we'll finish it, inshallah. Hess law. What is Hess law? Hess law is to find the heat of a reaction from 2 or 3 or 4 different other reactions. You add these reactions together and you will get to your reaction. What do I mean? This is called Hess law. Okay, it's a state function. The heat is state function, the enthalpy, I mean, not heat, but enthalpy is a state function, and that's why we can use Hess law to calculate delta H for a reaction from different reaction. Example, this one. I have 3 reactions here, 1, 2, and 3. And from these 3, I want to get to this reaction net. What I'm looking for this one. So how can I find the heat of the last one? I can see here the NO is available here and available here. So I will keep the first reaction as is. In the third reaction, I have 1 O here, I have 2 O here. So how can I make third reaction? What should I do to make third reaction to give me only O? I will divide this, reverse reaction, and divide by 2. And as a result, delta H will be the same. So I have to, delta H will be minus 495 divided by 2. First one, I kept it as it is. So delta H is equal to 198.9. Okay. How about the third one? Now I have in this side half O2, and I have 1 O2 here. But this is reversed, of course. You have to reverse the reaction. Reverse the reaction. When you reverse it, you will have. And what should I do to get rid of this O2 and have O2 from here when I reverse the reaction? Because this reaction will be O going to half O2. And this is delta H for this reaction. Okay. Now, for this one, I need also to reverse it. So it will be 3/2 O2 goes to O3, ozone only, and delta H in this case will be simply plus 142.3. Why did I do this? Because 3/2 O2 will go with half O2 plus 1 O in the product, and the net will be simply, and of course, as we said, NO will be here, O will be also here, NO is here, we still have O3 here, will cancel with this one. Now you add these numbers, which is 198.9, 142.3, 495, and the delta H will be, in this case, delta H will be equal to 900. You just simply add these 3 numbers together and you will get that it is 93.7, 93.7 kilojoule per mole. Let's see. The first one. Oh, first one. I should put minus here. Sorry. So erase this. First one, I did not reverse it or anything. That's why it is minus 198. So 198. And if you add these, it will be 304.1. And this is the correct answer. That's the solution for this reaction. Next, sample problem. Again, I have 3 equations, 1, 2, and 3. And I want to do delta H for this reaction. Okay, I have SO2, not 2SO2 here. This is 2SO2. What should I do with the first reaction? Reverse it and divide by 2. And what will be delta H in this case? Plus 602.8 divided by 2. That's the first one. So I have now SO2 as a reactant. Next, I want ozone as, or let's go with SO3 first. I want SO3 as a product. This here product, but I have 3 SO3. What should I do to make it only 1 SO3? I will divide the whole equation by 3. And of course, I did not change the sign. I did not change the reaction. So this is minus 1485.03 divided by 3. Okay. And next, the last question is, I want also ozone here. I want 1/3. What I have here is what? 1. Not only that, and this one in the reactant, I want it to be product. So what should I mean, it's react product, I want to be reactant. What should I do? Reverse reaction and divide by 3. As a result, delta H will be minus 142.2 divided by 3 also. Now, if you add everything, you will get the answer, and I hope we did it. And if not, these are the solution. Now, that's what I did. Reverse, I mean, keep the second one, but divide by 3, and third one, reverse it. And this is how to calculate the solution. I hope this is clear. Next, standard enthalpy of formation. Standard enthalpy of formation, we represent by H, and then we put F here, and standard, we put circle here. Formation, what's formation means? Making. بالعربي التكوين. Okay, حرارة التكوين. It's called حرارة التكوين. In your book, at the end of the book, there is appendix 2 at the end of the book for the heat of formation of many compounds. Many compounds. Go to appendix 2. Don't memorize anything in that appendix, of course, but go to appendix 2 at the end of the book, and you will find the heat formation for many compounds. Now, if you have them, then there's a rule. Delta H of reaction, Rxn means reaction, is equal to what? You have to multiply the coefficient of the compound by the heat formation of any compound, and the product, we will give them all plus, or take the number as is, and for the reactant, we make minus A, which is the coefficient for A times heat formation of A, and B times the heat of formation of B, which we can get from the book. All right, good. Let's have example to solve this reaction. So you need to memorize this equation. It's very easy. You don't need to memorize it. You need to know it actually. This is summation of all product minus summation for reactant. Example, if I want to calculate the heat of formation of this one, what is it? Delta H of reaction, Rxn, equal to heat of formation of AgCl, and I will multiply it by 1 because there is 1 here. And I will keep it as it is, okay? Minus heat of formation of Ag plus, and also I'll multiply it by 1 because this is 1. So no need to put the 1. Plus heat of formation of Cl minus, which is also 1 here. So we'll not put anything here. Now you just take the numbers, and now delta H reaction equal to what? The heat of formation of AgCl is minus, and I keep it as it is, minus 127.0. Then this is minus heat of formation of Ag plus is plus 105.9, and heat of formation of Cl minus is minus 167.2. Do it very quickly so that everything is multiplied by 1 only because the coefficient for these are 1. And the answer would be, if you add these numbers here, will be as simple as that, 65.7 kilojoule with a minus sign. With a minus sign, kilojoule. That's it. As simple as that. So you should go find the heat formation of these compounds and calculate the heat of reaction. This is the solution for this question. Next. Also, what is heat formation? Let's go to the title. Heat formation, standard heat formation, which is this one, is defined as, the heat changes that from to make 1 mole of a compound from its constituent element in their standard state. What do I mean by standard state? I mean by the standard state, if you go to the periodic table, all the elements in the periodic table are in their standard state. Whatever is solid is solid. I told you this in chapter 2. In periodic table, you should know by now where are the solid, where are the liquids, and where are the gases. All of the elements in the periodic table, the heat of formation for these things are equal to 0. So what's the heat of formation of Na solid? It is equal to 0. What's the heat formation of H2 gas? It's also 0. What's the heat formation of argon gas? Is also equal to 0. Heat formation of K potassium solid equal to 0. Cl2 gas is also 0 because Cl is available as Cl2 gas. Also, I told you if we have Br2 liquid, what's the standard deviation? I mean, standard enthalpy of formation, 0. and also I2 solid. I told you iodine is available as I2 solid. Also heat formation is 0. How about Hg liquid? Heat formation is 0. All of these are 0. Heat formation of carbon solid is also 0. Anything nitrogen into gas is also 0. And we have to put the standard, I mean the physical state, which is solid or gas or things like that. Okay, good. Now, if I want to write an equation that calculates standard heat of formation, I should have it an equation to make 1 mole of anything from its constituent, from the basic element. That's the heat formation. Let me give you an example. Let's solve this problem to have this equation. Here, I want to know, calculate the standard heat of formation, enthalpy formation of acetylene, C2H2. So C2H2 is what I'm looking for, and this is gas, of course. And I want to calculate delta H of formation. Delta H of formation. So what's the reaction to make this heat? You have to make this compound, 1 mole of this compound, which is 1 here, you don't have to write it, from basic constituent. What's this consist of? It consists of carbon as graphite or solid, graphite, because carbon is available as graphite, which is solid, okay, plus hydrogen, which is available as H2. Of course, I need to balance the equation, so I must multiply this by 2, and the H2 gas, give it as it is, and I want to calculate delta H formation for this reaction. Now, how can I do it? I can do it using these 3 equations. Here, what should we do with the first reaction? I now will use Hess law to calculate heat of formation of C2H2. How? By Hess law, I will keep the first equation as, first equation I multiply by 2 and keep the same thing for the heat, so I multiply this by 2. How about second equation? I will keep as it is, because I want hydrogen here, it's also hydrogen here. Okay, how about third equation? Reverse and divide by 3. Oh, sorry, by 2. By 2, because I don't want the 2 here. I will reverse the equation and subtract 2 from each one. And if you do that, you will be able to get these equations and you can calculate. Now, this reaction is heat of formation of a compound, making an element or compound, sorry, making the compound from basic naturally occurring elements. How is it available in the periodic table? And always I'm looking only for 1 mole. I cannot do it for, if it's 2 mole, it will be twice the amount of heat formation. And when we finish chapter 7, please, chapter 5, so we finish chapter 5. Please review it very well for the lecture. Thank you.